Hello everyone, welcome to Simplilearn's YouTube channel. Today we will be discussing about greedy algorithms in data structure. But before we begin, let me tell you guys that we have daily updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological advancements, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without any further delay, let's get started with the agenda for today's discussion. We will start this discussion by understanding the real-life example of greedy algorithm, following which we will deal with the introduction to greedy algorithm. Advancing ahead, we will understand example of the greedy algorithm. Once we are done with that, we will look into the demerits of using greedy algorithms. And finally, we will cover the applications of greedy algorithm to understand how we utilize it in our daily lives. Now, let's get started with our first topic. Here, we will look into the real-life example of greedy algorithm in order to understand it better. This is Alex. He's quite wealthy and intelligent as he works for one of the most reputed IT firms. And this is Alex's best friend, Rachel. Rachel is in dire need of $85 right now. However, she needs money in such a quantity that the number of coins is kept to a minimum. So Rachel shared this issue with Alex and asked him for help. Now Alex is thinking about Rachel's issue, which he can easily fix because he has a limitless supply of $50, $20, $10, and $5 coins stashed in various bags. Although this being said, Alex needed to think about the constraint Rachel told him about. He needed to give her money such that the number of coins utilized must be minimal. To do so, Alex began making a list of the various coin combinations in which he could present money to Rachel. However, after a while he became confused due to the vast number of conceivable combinations. So he decided to use his programming ability to solve real-life problems. Alex developed a program that will provide him with the optimal number of coins that he can present to Rachel. This generated program was iterating through the different possibilities to choose the best solution. At each iteration, the program added the coin of the largest value that was not taking Alex past the amount to be paid, which is $85 in this case. For $85, the largest denomination ID can start giving is $50. Now, ID is still short of $35 to reach the amount so that the next largest coin program can take in as $20. But since the program still requires $15 to meet the threshold, the next highest denomination it can accept is $10, followed by $5. The best part about this program was that it allowed Alex to present $85 in just 4 coins, which is fairly incredible. The vital thing to note here is that after each loop, the program makes a greedy choice, providing the coin with the highest potential value. What I mean here by greedy is that locally optimal choice is picked at every step to reach the global optimum solution. Now moving ahead, we will formulate the idea of greedy algorithms. Basically, a greedy algorithm is based on a problem-solving method that involves making locally optimal decisions at each stage in the hopes of achieving a global optimum. That means at each stage we choose a locally optimal value in the hopes of arriving at the optimum possible end result. Furthermore, this algorithm is an optimization technique that can find either minimum optimum result or maximum optimum result. The best part about this algorithm is that it is simple to understand and implement as well. Additionally, the runtime complexity for this algorithm is pretty reasonable. However, the fundamental disadvantage of this strategy is that we only receive the globally optimum value in a small percentage of cases. Having said that, you must be thinking about when to implement this algorithm for solving particular problems, as it does not always produce globally optimum results. Well, let me tell you guys that we have 2 conditions to judge our problem for implementing greedy algorithms. The first condition is the greedy choice property. This notion states that making locally optimal judgments can lead to the global optimum solution for a given problem. The second condition is about optimal substructure. The problem has an optimal substructure only if an optimal solution to the entire problem comprises the optimal solutions to the subproblems. In simpler words, That means the problem can be split down into multiple subproblems, and the solutions to these subproblems can collectively lead to a solution for the entire problem. If both the above-mentioned properties are satisfied by the problem, then we can create a greedy solution for that particular problem. Moving forward, we will look into the steps for constructing a greedy solution. Finding the substructure or subproblem that can lead us to the final answer is the first step in building a greedy algorithm. Because in this algorithm, we are just trying to operate with local optima to reach the global optimum solution. The second step is about determining the type of solution the given problem can result into. That can be either the largest sum or minimum path. The final step for creating the greedy solution is about creating an iterative process for traversing through local stages and making decisions to reach a globally optimum solution. Now, you might be confused about how we can do that. Well, let's go through an example to understand the approach to implement a greedy solution. The example that we are going to deal with is called the traveling salesman problem, in which a salesman is supposed to reach the destination from a given current location. The representation of cities and paths connecting them is done using graph structure, where each node is considered as a city and edges connecting them as paths, having edge weight as the distance between the two cities. Now, in this case, we are supposed to find the minimum path between two cities. So to do that, we will begin from the current arbitrary position. From this node called as starting location, there are 3 possible paths. But the path towards city B has less distance. Hence, we will traverse this edge primarily as it is an optimal local route. We have reached city B now, and from this node we have 2 possible paths, out of which one path directly leads us towards the destination city having distance 20, but the other path leading towards the city F has edge weight value or distance value as 2. Hence, according to the local optimal decision, we will choose the edge connecting cities B and F for traversal. We have reached the city F now. From this node or city, there is only one path leading us to our destination. Hence, we will traverse it. Now we have reached the destination city. The path highlighted in the green shade is the global optimum for this TSP problem. You can verify that by calculating the edge weights for all other possible paths. Since the solution allows us to reach the global optimum by making optimal decisions at the local stage, this strategy to solve the problem will be considered a greedy approach. Now moving ahead, we will look into the demerits of using greedy algorithm. We have learned that the greedy algorithm makes decisions based on local optimum instead of analyzing the broader picture of the whole data. Hence, there is a possibility that the greedy solution might not be the best optimal solution for some problems. For example, consider this traveling salesman problem. In this problem, the highlighted part is a created solution to reach the destination city from the current location using a greedy algorithm. But if you observe this graph, the selected solution is not the global optimal solution for this problem. In contrast, it is the worst generated solution to reach the destination. That is why the greedy algorithm is considered to be prone to correctness issues. Even if the algorithm is correct, proving why it is correct is difficult. Thus, it is deemed to be trickier to solve specific issues. Now, we will discuss about applications of greedy algorithms to understand their importance. The first application of a greedy algorithm is its use for constructing minimum spanning trees. The coding approaches that we use to generate MSTs is based on the greedy algorithm. Both Prim's algorithm and Kruskal's algorithm are known as greedy algorithms as they make decisions based on locally optimal decisions. The next application of the greedy algorithm is its use to implement Huffman encoding and decoding algorithms. The Huffman coding technique is a lossless data compression method. The concept is to give variable length codes to input characters, the lengths of which are determined by the frequency of the related characters. The smallest code is assigned to the most frequently occurring character, whereas the largest code is assigned to the least frequently occurring character. This process is carried out by making local optimum decisions. Hence, it is also considered to be a greedy algorithm. The final application of the greedy algorithm is its use for developing solutions to well-known coding problems. Those problems are the activity selection problem, job selection problem, and fractional knapsack problem. All these problems generate solutions by making decisions at each local stage. So the solutions for these problems can be developed quite easily using the greedy approach. So with this, we have come to the end of this video. I hope this video on greedy algorithm was informative and interesting. If you have any queries regarding the topics covered in this video, then let us know them in the comment section below, and our team of experts will get back to you. Thank you so much for being here, and do watch out for more videos from us. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.